Okay, so welcome to the first lesson inside of Grasshopper. I'm gonna try to keep it fairly simple because you can actually go on, well, I can go on tangents that last basically hours, but I'm gonna try to basically give you the simplest way to sort of start doing some cool stuff, just to sort of help you get to know Grasshopper. So I'll go slow and I'll try to explain part of the process. But this is very much a basic intro, so I won't go too deep into the more complex parts of this, but I'll make sure that you guys have some cool things to do. So the first thing you do obviously is you install Grasshopper. Grasshopper is a plugin for Rhino. It won't be a plugin for long. The next Rhino will have it natively. And then once you load it, the way to turn it on inside of Rhino is to go to your command line and click on and write Grasshopper, and then it'll turn on. And also while you're at it, we're going to be using the plugin Lunchbox, and this is a really great plugin to sort of get you going before, so you don't have to do too much crazy stuff, and you could get some pretty cool results. So the first thing we're going to do is add a surface to our Rhino file. So first turn on your grid snap, and then just here in the tool panel, just add a surface, and we'll keep it from, let's say, we'll go 40 to 20 millimeters. In the bottom left corner, you could see where it is. If you have it still like a wireframe, to see it shaded like that, you go here and you press shaded. And actually, I don't need to see the other views right now, so I'm gonna go full screen. And also, I don't really need to see the grid anymore, so I'm gonna go grid, and then I H to sort of hide the grid. And there. So the next thing I usually do is I select the surface, and then I add it to a layer called surface, and then now it's here, so I could hide it if I want. But yeah, that's how we're gonna start. So once you load up your Grasshopper, you'll see it's a fairly weird if you've never done this type of workflows, it's a little hard to understand what's going on. But basically, this is the canvas, and here this is where you start writing your algorithms, and to input this surface into my algorithm, I need to put it into my algorithm. And the way to do that is here in these tabs, you have the parameter tab, and here in geometry, you could select what type of things you want to add to the scene. So here I'm gonna go to surface and click on it, and then I'm gonna put it here. And see, there's still, all I did is add a surface, an input for the surface, but there's nothing there yet. So to add this, you select the surface, and then you right click on this component, and then you go set one surface, and there. Now this surface is inside my algorithm. So now I don't need to even see the actual surface that I'm using. I could hide that away. And now all we're looking at is the preview of the algorithm. And to change that in terms of the color and stuff, you could click this button, and then here you could change how it looks in your screen, or add some transparency. I'll probably add a little transparency on this one too. So now we have this surface in our algorithm. And now that the next thing we're going to do is, just to keep everything quick, we're going to go into Lunchbox, and then we're going to click on this hexagon cell, and we're going to place it here. And as you can see, once you put it in here, we have a lot of options. So here it says surface. This is where we input the surface to this component. So once I connect it, see, now I have these hexagons in there. And then here's the U and the V. If you're not too familiar with NURB modeling, U and V are basically the directions of the surface. It's the same as left to right, top to bottom, except that this is how they sort of this is how they're labeled in computers, in NURBS. So when you select something, you can hit the space bar, and this radial menu comes out, and then you can hide it. So because I don't need to see my input surface, I'll just hide it away. And now all I have is the hexagons left. So if I right click this and press help, here you can see what it actually wants. So surface, and here it says it wants an integer as in a number, and for the u direction, and another integer for the v direction, and another number for to transform the hexagon angle. And the difference between an integer and a number is that an integer is basically just a whole number, as in instead of 1.152, it's 1, 2, 3, and a number can be anything. So first let's add a regular number to our t parameter, and to add a number, we're gonna go to our parameters, then we go to input, number slider, and then you select the number slider, and then you select the canvas. And now we connect this to this, and there was no difference, and that's because that's the 0.25 is where it's naturally at, or where it's set for the beginning. But if I move this around, you see it moves it changes the angle of the hexagonal grid. And then here in U and V, I could add how many I want in terms of the ratio and the number of hexagons. So I'm gonna go back into my numbers, get another number slider, and then to change the number slider settings, I'm gonna right click it, and here in values, I'm gonna go max. I'm gonna go 10 for max, and press commit change. And also I don't want the 0.00 numbers, I just want the whole number, so I'll just go integer. And there, now I have that. I'll now control copy, control paste, then go here and connect this here. So now I could sort of dictate the number of cells. And what I actually do is I know that when we built it 40 by 20. So I know that the ratio is 2 by 1. So I'm actually gonna keep it. I'll keep it. Well, actually, I could do 2, 1, 2, like that. And then I'm gonna actually use math to sort of to control that aspect of my design. So we go here to math, and then we go to operators, multiplication, like that. And then I'm gonna control copy and paste. So now I'm gonna connect the 2 here, and I'll go to 10 and connect the 10 here. So now if I connect this here, now I have 20, and then I'll do the same, control copy, control paste, and instead of the 2, I'll connect the 1, and then I'll connect this to this. So now I have a nice squared up pattern, and now if I could control the resolution of the pattern, or the density of the pattern, like this, and my ratio will stay the same. And now that it's a little more balanced, you could really see what the angle does to it. So see, now we're already sort of we're getting to do some cool stuff. Another thing too is I'm gonna basically start organizing everything. I kind of want to give you guys start giving you guys proper or good habits in terms of organizing stuff, because after even though these are very easy, after a while it gets really difficult to control where everything is at, and you really need to start sort of cleaning up as you go, or else it'll be a huge mess. So one of the ways I do that is I hide my lines, and then all you do is you click on it on the where you put the line, and then wire display hidden, and then here too, wire display hidden, wire display hidden, and you just keep going, and wire display hidden. So now if I go here and here, I could basically put this here, and I will put this here, and I want to start labeling them, because then I'll start getting confused. So a way to do that is you use the scribbles. So the scribbling is I think it's here. I actually don't even know where it's at in the, where is it? How I actually usually find tools is actually I press I double click and then see this enter search keyword comes out, and then I start writing the letter or whatever the tool is called. And as you can see, my tools, they have their icons. To change that, you click here. Where is it? See, in draw styles, draw icons, because if not, then you'll have the letters. But personally, I like using the icons. So as you can see, when I added the scribble, I added this. So I'm gonna double click it, and I'll put here ratio, here density, and here I'll put hex angle. So there you go. And now let's just keep going. So just to kind of show you some of the things we could already do. Let's say I wanted to scale all of these hexagons, right? I could use my scale tool. So you go to transform, and then you go to affine, and then you click on scale. And then so basically scale is just scaling, right? And we have the factor here. So if I add my number slider, and keep it at 1, if it's a factor of 1, whatever I add nothing's gonna happen because it's at 1. But if I go down, see, I'm scaling it, but as you can see, it's getting scaled down to the middle point. I don't want that. I want it to get scaled down by their own center. So here, as you can see here, the tool gives you the centers. So you put the centers here, and then there. See, now we're trying to do some cool stuff. And then I'm gonna select it, and then press spacebar, and then press here to hide it. So now we have this cool little scaling, and we could change the angle, and we could change the density. If I ever want more density, it's not like I'm stuck to anything. I could always go back to values, and then go 100 if I wanted to, right? Commit changes, and then look. It starts getting pretty heavy if you do too much, but I'm just trying to show you guys that you could do whatever you want. So actually, I kind of like we'll keep it at 10. All right. So now, so this is a very simple algorithm, right? But I want to sort of show you guys how to do a little more things. So the first thing we need to do is add a point into our algorithm. So you go here to standard, and you add a point, and now we want to add that point into our actual algorithm. So we go to parameters, geometry, point, and then you add the point. And then I right click it, set 1 point, and see now that point is in my algorithm. And I'm actually gonna add a new layer, or I'll change this layer into inputs, and then I'll add that here. Actually, I'm sorry, because I kind of want to show you guys something later. So I'll put the point in this one. Change object layer, and then for right now I'll hide it away. So that point is right here. And also I don't do this that often anymore, but usually I would put something like inputs like that here, right? Okay, so what I'm gonna do is actually I'm gonna use that point as what is called in Grasshopper terms an attractor. I want to scale these based on their distance to this point. So I'm gonna slowly do that, and as I go through it, I'm not gonna explain too much of what's going on the algorithm in the data of it and the data tree management of it. Those concepts I'll start approaching them a little later after we get past this. So what I'm trying to find is the distance between this point and the rest of the centers that were here, right? So right now I only need the centers. So a way to sort of see them without having to see the other stuff of the component is I just want this one, right? So I could go here, back to parameters, grab the point, put it here, and if I connect these cells here, see now I could see my parameters. And now, like, let's say I'm gonna measure the distance between all of these and this one. And a way to sort of visualize that, I'm gonna add quickly, just to show you guys, a line component. So we go to primitive line. So if I connect all the centers to the bottom one, and then on the input I add that main one, you see now everything is connected to that point. So if I open that point again, and if I move it inside of Rhino, you see how they're all getting connected to that point. That's basically what we're gonna do, but with measuring the distance. So I want Grasshopper to tell me what is the length of all of these lines. I want to know the distance, right? So instead of a line tool, I will use a distance tool. Distance, and I think also to actually, I think it was like this. No, there we go. If you ever forget where a tool is and you found it through here, you know, like doing something like that, a way to sort of figure out where it's from or where it went, if you press Control and Alt and then press the thing, it shows you where it is and where, and you know, so it's under vector, under points, and that's where you can find that. So it's the same thing. Now I want the distance from that point to all of these points. So I don't actually need the line for anything. It was just to sort of illustrate what's going on. So let me show you what's happening to the actual data of this. And I'm gonna hide this because I don't need to see it right now. Hide. And technically I wouldn't need to see this either. I could kind of just connect that to this. You know, all I did right now is just so I could see them. But nothing's happening to the data, as in the points are here. I'm connected to this thing, which is just collects points, and then I'm merging them to that. So, but this thing isn't doing anything but holding on to information. It isn't manipulating it. So if I went here, it wouldn't change anything. But for right now, just to keep everything a little more clear, we'll keep it like that. And to actually see what's going on is you could use here an input in the parameters panel, and you put it here. And when you connect it here, you start seeing all the different, these are all the distance to, every point's distance to that point we put. So you see all the different numbers. As you can see, they're everywhere. And I want to use this information to scale my hexagons. So the tool we're going to use is we're going to remap the domain, and this is where, and I'll start slowly explaining what that is. Okay, so to go further into our lesson, I need to teach you guys about domains and remapping numbers. So the first thing we want to do is construct a domain. So under math, go to domain, construct domain, and put it in your canvas. And this is just a quick exercise to sort of show you guys what domains are, what does remap numbers do. So if I add a number slider, and in the number slider we'll go to slider type integer, and then value max we'll go 10, right? Commit change. So I'll put the 10 here, and then the beginning of my domain would be here. So now I just made a domain from 0 to 10. If I connect the panel here, you'll see that that's the domain. And now we're gonna use the remap numbers component. So remap numbers. And as you can see, let's work with 3. So I'll put in remap numbers, that's basically what the name is, what it's doing. It's just remapping the numbers to a different domain. This is this is my starting domain 0 to 10. So here I can see or source domain, and another one is the target domain. So my source domain, I'm gonna connect it here, and then I'm gonna copy all this, control copy, and then paste. And then here I'm gonna put the value to 100. Okay, and then that I'm gonna put in my target. And then I'm gonna connect here, V is for value. So we're gonna connect the 3 here. And now when I get the result, see, right now nothing's happening because the domains are the same. But once I change this domain to 100, see, it changed the number to 30. So basically what happened is it looked at this domain, and then it saw where the 3 lands on that domain, and then it looks at this domain, and it uses the percentage to find exactly where that is. And obviously this is a very easy mathematical problem, right? If you have 3 and you only have 10, you know, that's 30%. So 100 would be 30% of 100 is 30. But you know, in here we get, what if it's 25? You know, or you wanted to know what's 30% of 80? You know, it doesn't. That's basically what remapping does. It finds the number where it fits in this source domain, and then it remaps it to whatever domain you want. And this is basically the underlying mathematics of scaling. So this is what we're gonna use to remap the distances that we have on the other algorithm. Okay, so now that we actually have, now that we've seen what remap does, let's apply that knowledge now into this algorithm. So first, let's add the remap number, and I need to make a domain, right? So let's go to math, domain, construct domain, and I'm gonna place it right here. And since I know I want to scale it, that I'm gonna scale it from 0 to 1. That's what I'm gonna do for my target domain, because that's basically what I want to do. I want to figure out the distance and then change that distance from figure out the distances of all of them and then remap them from 0 to 1. So a way to figure out what the distances are, right? We already saw with the panel tool, we could see all the different numbers, but they're not in order. You know, they're just sort of, they're not random, but where the point is. So a quick way to find out what's the smallest number and the highest number, to basically build a domain from the highest and the lowest, is by using this tool called bounds. So if you double click it, and BOUN, so that's bounds. And to find it, it's actually in under math, domain, and then bounds. And then you put it here. And when you connect the distances, and now when you connect that here, so now I know that the closest distance between the cells and that point we put is 1, and the farthest is 27. So that's our new domain. So we're gonna put this domain here as our source, and then for our values we're gonna use the distances, right? So we go like that. And then for our target domain, we're gonna use the 0 to 1. So if I get this scaling and I place it over here, I don't need this factor anymore, because I got the results right here, and I connect them here. You see now it's let me see why it's theirs. Oh, now as you can see, it's scaling, and it got red because I actually hit 0. If you scale anything times 0, it vanishes. So that's what it's kind of telling you. So if I go like that, see it now it's happy. And as you can see, the cables are kind of running through each other. I sort of have a rule of if if the cable of the box goes through anything, I just hide it. I go wire display hidden, wire display hidden, and that just keeps everything a lot more organized. And I could always know, you know, the flow of things just by looking at that. And then also, it's always nice to sort of organize everything. So now I could actually, I'll select these and I'll hide them. So see, now we actually have this cool attractor, and there's no limit to, you know, what you can do with it if you move around the target domain, you know. And I use this a lot. I definitely use this a lot with when there was a lot of criteria, you know, where they're like, okay, we can't get it smaller than this, so now we'll so we'll leave this at 0.3, and then from there we'll go up. So now we know that the smallest one is always going to be at 0.3, and as you can see from the grid, it's already kind of doing some cool stuff. And since by the nature of algorithms, right? If I go back to here and I get the density up, the difference is difficult to tell because I left it very minimal. But let me do something like that. See? And that's basically how an attractor works. And this is a very simple example, but I'm gonna do some more things to sort of to have some cool effects. So yeah. Okay, so now we're actually gonna get even trickier. What I want to do is actually I don't want to have the whole grid in my algorithm. I sort of just I want to use the distance of this point to, if I move it around, to sort of just find whatever closest points are to it, and then delete the ones that aren't here. That way I don't have these edges. I kind of want to just have like a circle. So what I need to do is basically some data management and some math. So instead of scaling, I'm actually going to use well, the scaling is going to come in later, but for right now I will delete this, and then so we could see what's going on, we'll go back here, or actually we'll go cells, curves, and then we'll go here. Okay, so what I want to do is I want to since we already have the values, we already remapped the values from, well, right now from 0.04 to 0.8, but I'm going to go back to 0 and back to 1. And then so basically now what that did is it gave it put all the distances from 0 to 1. I know I'm repeating myself, but I feel like it's especially the first time you do this, it's very confusing. So so I will be repeating myself multiple times. So if I go back to the results, you know, using my panel, right? So now all those distances are relating from 0 to from 0 to 1. If I copy that and I use this, see, so the one on the left is the new remap numbers, and here on the right is the actual distances. So now I actually want to use a way to get a percentage out of there. I want to know I want to get the closest 30%. So how you do that is with math. So you go to math, and then you go to operators, and operators, and then I want everything that's smaller than 30%, right? So here's you know, I have to add my results here, and then for 30% I need a number slider, and then I go 0.3, and then I click that here. So what happened there, if I go back into if I use my panel tool to see the data, see how it says false here? What it's basically doing is it's going through all the numbers, and it's finding what fits under the 30% and what's over the 30%. And now I want to use this data to manipulate my cells. to use it as a way to sort of, it's called culling, which means it basically removes it. I wanna keep all the true and remove all the false, and the way to do that is with culling. So you go to sets, sequences, cull pattern, like that. And then here it's asking for the pattern, and this is the pattern that we developed. And now it's asking for the list, and let me once I connect it, and then I hide these. See, now I get the closest 30%. So just to go over what is happening, here this cull pattern is removing all the stuff that anything that's above 30% of the distance. So I could change that, and this sort of gives me this effect. Now what if now I sort of want to use, I like this, but I want to return and use my scaling again. And the other good thing, you know, since it's parametric, you know, you could always move it around. So now I want to do what we did last time, but with another scaling. So the first thing I need to do is actually get all the distances and use the same technique of deleting the ones I don't need with this tool. So with the culling pattern. So I'm going to control copy and paste. And then here on the list, I'm going to actually attach the measurements. So here's the distance, and I'm going to attach them here. Now, remember this, we made this pattern, you know, based on, but I'm using that pattern to manipulate different data points. When before I did it just to eliminate the cells, but I also want those distances that we took originally, but I don't want everybody else. I also only want these. So I'm using the same thing. And if I look into the data, you can see it like that. So see, now we can see here that there's only 249 curves, and now there's only 249 distances, distance measurements. They're the same. So if I go back to this distance and I put it here, see, this is the rest of it, 884. But I don't want all of those, because I only want to use the distance that is left, not of the whole thing. So now I'll do the same thing I did last time. I'll actually just copy, control copy, paste all these. And now instead of all of the numbers, we're gonna connect these here, and then also the same thing with the bounds. We're gonna connect that here, and then we don't need this anymore. And just to keep everything again clean, I'm gonna hide it, and I'm gonna hide that line too. So now I'm gonna I'm gonna scale them using my scale tool. And the other thing I'm missing are the points. And so I'm actually gonna use this cull pattern again to eliminate the rest of my points, right? Because now I have all these, but I don't want those. I just want the close ones. So I'm gonna copy this and paste it, and then instead of the cells, I'm gonna get the points, and I'm gonna put them here. So now when I remove these, now I got the centers again. So as you can see, the cull pattern, the pattern doesn't care what list you put on here or how you got the list. All it does is it looks at the true or false, and then it applies it to whatever you put it on top. So now I'm gonna connect the cells up here to my scaling, because this is where you put the geometry. And then I need the center points, which are here now. I'll put those here. And then now I'm gonna use the new attractor here. So if I hide all these, see, now we actually have something pretty cool. And and now we could use this for a speaker or whatever we want. And if you see, everything is still live. I could always change any of the settings I want, and also the density or whatever. I'm actually I'm gonna show you guys one more thing. Instead of, because we're using the distance between a point, but that's not the only thing we could use. We could, if I go to my Rhino and I get the curve tool, and let's add a curve sort of like that, right? This curve, I'm gonna add it to my algorithm, curve, and then set one curve. So now that curve is inside the algorithm. And remember when we got the distance, I want to see the distance not to one point but to the curve. So I gotta use here in curves, in analysis, there is curve to closest point. So this tool, basically you input a curve into it, and then you input all the rest of the points here, and now it's the same thing. You get that distance. So if I add that distance, if I add the distance, which is here, into here and here, see, now I'm using that curve to control the same thing. And now I'm not using anything. Oh, and I have to put this here too, because remember that through the algorithm we sent this distance to here, and then we remapped it. So we actually have to remember to connect whatever is in this one too for the distances. And so we go here and we connect it here. So now that this curve is, if I hide it, that curve is making this line. And I could always start changing everything around. And so basically that's kind of how this is how you start building these types of algorithms. And after this, I'll show you how to take these into Illustrator and also Alias, so you could actually start using them right now. So before we actually go into Illustrator or Alias, I'm gonna do just a little bit of cleaning up, and also I'll show you guys about grouping and how to actually internalize data, because I'm gonna actually, you could download this file and play with it when in my site, so that at least you have something to sort of reverse engineer if maybe something was too complex. So the first thing I'm gonna do is just organize stuff. So I'm gonna do this, and this is actually, it's gonna be very much organized to help you guys. Usually I'm a little more dry in terms of my own. I don't really need this much, but I feel like it would help out. So I'm gonna group these. To group something, you select it and you press spacebar, and then there you group it like that. And then you could now they're nice and in order. And I'll put this over here, and then control copy paste, scaling, and then this is the percentage, right? So hide, and then we're gonna take the percentage over here, and then we're gonna call it distance threshold. So I could use that to control that. And also I'm actually gonna, let me put my curve input This I don't need. Do I? Oh, I do. Well, actually, I guess I don't technically need it. So we'll put that like that. Could delete that. And then this, like I said, you don't actually need these, but you know what? I'll leave it so that you could kind of like see what's going on. So this is, and another way, if I know something is always gonna stay constant, like I'm not gonna move it around. For example, here, I could actually internalize all this. I could either go here, and go internalize, and go here, and internalize, and so now I don't need that. That information sort of got stored into this thing, and also even this thing could be stored into here. So, but for right now, we'll just leave it like that. And then this was the other one. So what I'm gonna do is also group all these like that. And actually you could group inside groups, and I'm gonna group these individually. Oh, and I'm gonna change the color. Oh, whoops, sorry. Let me try that again. Ah. Okay, ungroup. We're gonna change the color. So first we go like that, group it, and then go here, color, we change it. Oh. Like that. There you go. And then these things we'll just leave like that for right now. And actually I kind of want to group them, and let's see if I can. Oh, it's because I'm doing it backwards. I'm sorry. I apologize. I know that I did this already. So let me change that to like, we'll change it to like a blue, right? And I want to use that blue again. So I'm gonna go here and go make color default. There you go. And then group, and then group. And now that, and the reason I did that is because if something's a group, I could label it, right click it, and up here, I could, first I want to see, well, I think this is the points, yeah. So I go here and I go points, and then here I go, these are the actual cells. So cells, and then here, I think this is the distance, right? Yeah. Distance, oh, whoops. Distance. Okay. So then I'm gonna you can group this, and then this will be the distances. And then this is the curve that I added into my scene. And you could actually even internalize curves and also the surfaces that we did in the beginning. And I'm actually going to do that because that way, once you download this file, you don't need to actually add the curve yourself. They'll be inside the file. So I right click it and I go internalize data. So now even if I would delete this curve in my actual file, it wouldn't matter because it's already inside. So then I'm gonna hide, and I'll put that here. And this one I'm going to internalize to, and this one I'm going to internalize to. So now basically I've internalized all my inputs, and now this algorithm is basically self-run. Even though this point, this point doesn't need to be here. I could just, like I said before, I can sort of, I did that to help you guys see what's going on, but I could always, I could see where it's connected and just sort of jump through it. And then this is connected over here, and then this is connected over here. So there you go. Oh, and then this is yeah. So what I'm gonna do actually is go like that and group this, and we're gonna call this curve distance. And we're gonna do also is control copy and paste. And then on this one, I'm gonna see where all of these are connected, and I'm gonna actually use this thing, use the original points that we did. That way, That way, you guys will have both. And a lot of times when I'm doing this sort of thing, like I know I want the distance of this curve, and I'm replacing it with this one. So a lot of times I'll just see where it's connected, and then I'll just sort of follow the lines and then connect this thing. And then so now I could delete that. We'll group that. We'll call this point distance. There you go. So I guess I didn't have to do this. I didn't have to do this part twice, but at least that way you can see both of them. So when you select all of them and you go unhide, see now you can see this one, and then if you go here, you could play with the distance, the scaling, all that, and then if you hide this one, and you should see this one. Oh, not this one. Now you can see the curve, and so yeah, that I'll leave this in my website to download, in the Grasshopper tutorial section, and so let's actually take this to we'll take it to Alias. So we'll use this one. So let's say I want to use this in Alias or Illustrator, but first we'll do Alias. Let me change let me change it up a little bit, maybe something like that. Okay. So first, what I gotta do is actually what it's called baking. So if I go here and I go bake, let me do that again because I know I can move kind of fast. I click here, right click it, and then here there's bake. And I click on bake, and then here it asks me if I want to group it, and I say yes. So now this is an actual, now this is actually real data that is inside of Rhino. So now I want to export this, export selected as an IGES. This is for Alias or any NURB modeling software. So we'll call this curves. Default, yes. Now let me open up Alias. Okay, so so now I have my Alias open, and this is Electra. I think I've talked about her enough, but let's import. First, we gotta import the curves that we just exported. So import file, import curves. Open. And actually, if I hide unselected, if I just hide everything else besides the, oh whoops, where is it? Oh, there it is. If you remember in the when we started this, we actually made it very small. So so if I zoom in with Alt L, see there it is, and it's tiny. That's because we started it with that 30 by 20 by 40 millimeter surface. So this is basically what it is in Alias. So first what I'm gonna do is move the pivot to the center, and I think the center point is, well, actually, you know what? I'll put in the center point, and then I'll move it. Oops. Then I'll move it and snap it to the center. Excuse me. And then we're going to scale it, and I'll scale it by 100. And then for right now, I'll put it in the roof of my car. I'm going to scale it down a bit. Obviously, this is not really my intention of any of this in terms of the design, but it's just more to show you guys. So after that, I select it, I project, I select the curves, and I project the curves, and then I trim them and keep. And there you go. Now I have a hex pattern for no real reason in the side of my car. But you know what? I think since we're really not that far from actually going to the second chapter of this lesson. I think I'm just gonna quickly show you guys. You could use if you remember in our algorithm we used an input surface. So I kind of want to use a surface from Electra to actually use to make my pattern. And I think for right now I'll use this door surface, and I'll hide unselected and I'll untrim it. And I don't want it to go that high up, and I also don't want it to, well, this length doesn't matter that much, but I'm just thinking out loud here. Okay, so what I'll do is actually delete this. Oh, whoops. I'm gonna control copy, paste, then I'll hide that, and then this one I'll as you can, I don't know if you guys already noticed, but I actually have most of my stuff hotkeeyed up, so I don't really. I could actually model like this, like that. Ooh. Yeah, we'll use that one. So then I gotta export this out, and let's, oops, file, export, active as, IGES, save, and then here we'll put input surface. Okay, and then I'm gonna open that up in Grasshopper. Okay, so now that we're back into Rhino, I wanted to show really quick how to use a surface from Alias into our algorithm and then send it back to Alias. So as you can see right now, it's still, the old pattern is still there, the one that we did. So for right now, I am going to hide it, and the first thing I'm going to do is actually import the surface we just made in Alias. And then also, I actually forgot to record this, but I also duplicated the edge of where is it? Yeah, as you can see, it's like how we saw in the other file, that is we're working in very tiny increments. So so if I go up here and maximize, see the door is way over here. And also it's really easy, and you go to properties, and then you go to grid, and let's make the grid into maybe every 100. I would do every 50. Every 50 millimeters, and this is every 25. Okay. So now we have the door that we did in Alias. And then the other thing I actually forgot to show you guys when I was in oh, I forgot that I wanted this curve. So in Alias I went back in real quick and I duplicated this edge, and then I exported it again as IGES. So input curve. So now we have that curve. Now let's put this into our algorithm. So we'll select the surface and we'll go here to inputs, set one surface, and then we get the curve, and we go here to inputs, set one curve, and if we turn this on, see now we're getting a pattern. And right now, let's see. That seems like a lot. Let's go back to here, and then we'll see. Okay, so now we gotta change the density to something a little better, and also the ratio. So something like that probably. Kind of like that. Okay. then let me hide this so we can see it. Okay. So then we could always change the angle a bit, give more distance. I guess something like, or we could actually go all the way too, if we really wanted. Yeah. Okay. And the reason why there isn't like a straight line, because remember, or like when the distance threshold, you would kind of think that this distance, well, that the distance threshold would sort of be linear, but if you see the distance between here and here and here and well, basically here and here, it's not direct, so it'll have some things sort of like this, but that's fine for our example right now. And then obviously we could change the scaling. We could do something a little more aggressive. Okay, so then we go back to here, bake, group, yes. It's basically, we're gonna do the same thing. You select it, file, export, and then as an IGES. And then we'll call this door pattern. Okay. And now let's go back to Alias. Okay, so now that we're back in Alias, we're doing basically the same thing I did a second ago, but might as well show you guys how it looks. Import, door pattern, open. And then see, now it's there. So I could pick that and sort of, and then just project it. And then instead of trimming it, or instead of discarding the other one, I'm gonna divide it. And then let's unhide, and we'll color it. We'll do it black. See, there you go. Obviously, this is a very simple algorithm. It's to me, I didn't do a lot of things I would do normally, because we would have to start talking about a lot more complex subjects, and to me, there's no point when you're just starting to learn Grasshopper. But I will say that I see a lot when I show people this thing, they sort of start running away, and they'll basically think that this is it, and they could accomplish anything. And honestly, Grasshopper, you don't have to become an expert on it to do things like this. But I do want to say that there's gonna be you're gonna hit a wall eventually, and to sort of overcome that wall, you're gonna have to start learning about programming, uh, calling, dispatching, series, sets, matrices, data tree management. It's very it's actually, it might seem simple what we're doing right now, but once you really want to start sort of making things a lot more complex, it actually gets very difficult. So it sort of has a learning curve where you start doing things like this fairly quickly, and you could get really far in that. But then a lot of times what I see is people actually, they'll stop learning, and then they're actually causing themselves a lot of work because they don't know how to basically control the data or the process. So they'll either do you know, everything else in Alias, or they'll just basically start making these ridiculously long algorithms because they don't know how to actually do the proper data management. So even though I know that this is, you know, we're already getting pretty cool results, I sort of want to just take this time to tell you guys that there's actually, this is just scratching the surface. There's a whole other world that I will show you guys in the video. It's gonna take a very long time. Um, and obviously, like I've recommended a bunch of books on how to on how you could learn yourself. But just remember that this isn't complex, and to really start doing some very cool forward because this is already, to me, it's already played out. I see it everywhere, and to be really honest, I get a lot of requests for something like this, and to me, I even tell my clients, like, yeah, I could definitely do this for you, but it's not that unique. A lot of people are doing stuff like that. So if you wanna sort of push it and do things that are a little more complex, it'll take a lot longer to learn. But I felt like this way you could at least start to sort of understand a little bit of the workflow. And yeah, so this is basically how you could do this simple algorithm, and I'll show you real quick on how to do it for the graphic designers that are looking at this video. How to send this to Illustrator, which is super straightforward and really easy. So yeah. Okay, we're actually almost done. So what you do, it's actually really easy. Rhino has a really good Illustrator exporter. So once you have the pattern baked, you select it and you go File, Export, Selected. And then here you go to, you select Adobe Illustrator. And then we'll call this pattern. And then you save. And here you could choose snapshot of a snapshot, snapshot of a current view, and that will kind of leave the measurements a bit random. Or you could also use preserve model scale, and then that gives you more control. It really depends on what you want to do. Usually I just since I'm not that picky on that, I'll just go snapshot of current view, and you press OK, and then that's it. You you get the file. The file just comes out like that. You open it. Oops. And that's how it comes into Illustrator. And usually what I do is I just select all of them and then I invert them right here. And that's it. And actually, I'll show you guys some other stuff that I've done with Illustrator and Rhino. And you could actually, there's actually a lot of graphic designers that are sending me emails, and also I hear a lot about how they're using Rhino and Grasshopper to develop these patterns. So I think it's really cool. I've made a bunch of projects that here I'll throw a couple up here when as I'm talking, and yeah. So this is basically how you could use Grasshopper for Alias and Illustrator. I have a bunch of different tutorials also on my site, and I'll have this file loaded for you guys, so you guys can just download it and sort of play around with it. But I always encourage to do this yourself first, and then try it, and then open the file and see where you messed up, or maybe hopefully you didn't mess up, and I was a good enough teacher. But anyways, yeah, if you actually do build something, or always send me an email, or if you have a question. I always like to see what people do. It's always nice. So yeah, I hope you guys enjoyed this video, and have a nice day. Bye bye.